let's discuss how to find the distance between the point 272 and the plane x minus y plus 2z equals 4. So to begin, it's nice when we have the equation of the plane because we can easily read off the normal vector as the coefficients of the variables. So we have 1, -1, and 2. So this is the normal vector for it. So in this particular picture that I've just taken from an online open source textbook called Active Calculus, this normal vector coming perpendicularly out of the plane or orthogonal to a vector on the plane is 1, -1, and 2. And so we have some other point up here in space. I'm going to, we can make it really anywhere. Let me put it over here. So I'm going to make this my point. We'll call it R. This is going to be 2, 7, and 2. Okay. Now what's beautiful about the normal vector and the idea that vectors are in equivalent classes is that this normal vector can be moved such that it is kind of coming out of another point on the plane. Let me do a better job. So it is coming out, so we basically move its initial end of the normal vector and send it passing through R in this case. Again, not the greatest line there. I don't think there's any cool, oh, there we go. So we'll call this now our new normal vector, and we still suppose that it is perpendicular to the plane, but instead now it is moving in the direction of R. All right, and so what we can then find is some vector originating from P naught, so in this case like this, going from P naught up to, not that far, but up to R. So from P naught up to R. And then what we can find then is this distance here, which is going to basically be the projection. So we can think of this as the projection of PR, the vector PR, onto that normal vector. I like the lowercase n. So that's going to be the vector going in this direction from the plane up to R. And if we find the length of this, so if we find then, so the distance then will equal the magnitude of the projection of P naught, or sorry, PR onto n. Now, in the discussion of the projection, we talked about this being essentially the magnitude of, to calculate it, it was PR dotted with n divided by the magnitude of n squared times that n vector. Now, remember, conceptually, we talked about this being a vector that moves in the direction of whatever we're projecting onto. In this case, it's the normal vector. So we're moving in the direction of n, and we've scaled it back. So another way I wrote this in my lecture was PR dotted with n over just the magnitude of n times n divided by the magnitude of n. And then we're talking about the magnitude of that. So this was another way that I wrote the projection to kind of give us this sense that n vector divided by its magnitude was normalizing it. Well, the magnitude of this is 1 because it's been normalized. And so this ends up being the magnitude of this particular vector, but we already know this is 1. So really, all we're looking at is this scalar value, P dot R. Oops, I shouldn't have a... PR, this is P, so PR dot N divided by the magnitude of N. Well, because we're talking about the magnitude here, this this PR vector dotted with the normal vector, we're just going to make it positive. So we can take the absolute value of the PR vector dotted with N divided by the magnitude of N. And what that ends up giving us the length or the distance from the plane to the point up here. So using this, in this example, PR is going to be the vector going from the plane up to this point. So we need a point on the plane. A real easy one to pick is it needs to satisfy our plane equation. So if x is 0, y is 0, and z is 2, then that's a point on the plane. So 0, 0, 2 is a point on the plane, and we're finding the vector that goes from 0, 0, 2 up to 2, 7, 2. So PR is going to be the vector 2, 7, and 0. So we've got 2, 7, 0 is PR. And then N, we've already wrote down, but I'll write it again. So N is going to be 1, -1, and 2. And so now we can find the distance using the dot product and the magnitude of the normal, because we're talking about the projection. So the absolute value of P dot R is going to be 2 times 1 plus 7 times -1 plus 0 times 2 divided by, and then the magnitude of N is going to be the square root of 1 squared plus -1 squared plus 2 squared. And so that's going to end up giving us, in this case, a -5 in here, but we're taking the absolute value, so we end up getting 5 on top and the square root of 6 on the bottom. So if we wanted to rationalize 5 square root of 6 over 6, but both of these are acceptable answers in the online homework system. So that is the distance. So what we found now is basically the distance from this point on the plane up to R. So that's how far the point R is, if we call this point R, from the plane.